Okay, so let me go ahead and share my other screen. So we can dive into today. So we're going to look at inscribed angles today. Some words to know. We have already seen arc. We're going to learn a little bit about a chord. We kind of did see it a little bit. But what we're really going to get into is inscribed angle, inscribed arc. And we, again, did see tangent of a circle last time. Okay, so these are different words we're going to see today. So just a general reminder what we learned about central angles. Let us remember that central angles are those angles which have its vertex at the center of the circle, and its sides are created by the different radiuses. Okay, remember that central angle. So the angle that's created about in there. So what we learned is that the measure of a central angle is equal to the measure of the inscribed arc. So the measure of the central angle is equal to the measure of the inscribed arc. The inscribed arc being the arc that is created near that central angle. So this would be our inscribed arc. And so what this is saying is that the central angle is equal to the inscribed arc. So if the central angle is 42 degrees, then our arc will also be 42. Okay? And we did see this. So just to solidify this, I'm going to post a poll. And you can just put what you think the answer is. So I'll launch it. So what is the measure of arc EG? So what is the measure of this arc right here, given what we just looked at? Just go ahead and answer the poll question. Or you can put your answer in the chat box also. Say A, B, C, or D. What is the measure of that arc? I see some of us answering the poll. So you can either answer the poll or put it in the chat box. What's the measure of arc EG? EG? Well, we know that the measure of the central angle is equal to the measure of its inscribed arc, right? So if it's equal to the measure of its inscribed arc, well, then we know that this is equal. And so 57 would be our answer. C. Good job, guys. Okay. Now we're going to go ahead and get into inscribed angle. An inscribed angle is an angle whose vertex is on a circle and whose sides are chords. So its vertex is located on the circle. This would be its vertex. And then its sides are created by chords. So these are its sides. And remember that chords go from one side of the circle to the other side. So this would be a chord and this would be a chord. So you can see how this differs from central angles, because central angles, the vertex is in the center of the circle, and then its sides are made out of radiuses, but an inscribed angle has its vertex on the circle, and its sides are chords, okay? And I'll go ahead and show you just a clear indication of what a chord is, right? We have a chord right here, from one side of the circle to the other side. Okay. So that inscribed angle creates an intersected arc, which is the arc that lies on the interior of an inscribed angle and has endpoints on the angle. So very similar to what we saw with central angles, this would be the arc. Okay, so we have an inscribed angle and its arc. Okay, well, what's the relationship between an inscribed angle and its arc? We looked at the relationship between a central angle and its arc, where they were equal. But what about an inscribed angle and its arc? Well, what this tells us is that an inscribed angle is half the measure of its inscribed arc. So instead of being equal to when we had central angles, now it is half the measure. Okay. So I can give us an example. If this inscribed angle is 24 degrees, how can we find the measure of the arc? Well, we could use this equation right here. So 24 is the measure of the angle. So it's equal to 1/2 the measure of our arc. Okay? To solve for this, we multiply by 2 on each side. And so we find that our arc is equal to 48. So our arc is equal to 48 because the angle is half the measure of that arc. Okay? 48 is half of 24 is half of 48, sorry. Okay. We'll look at some more examples. Okay, so just a quick check for understanding. Let me launch the poll. What is the measure of angle CAB in circle O? So what is the measure of this angle right here? What is the measure? Given what we just learned about inscribed angles and arcs. And again, you can put it in the chat box or answer the poll. I'll give you guys about a minute. What is the measure of angle CAB in circle O? A hint is that CAB is an inscribed angle. It's not a central angle, it's an inscribed angle. I see some of us answering the poll. Enter the poll or put it in the chat box. Just about 30 more seconds. Okay, and so what did we see? We saw the measure of the inscribed angle is half the measure of the inscribed arc. And so that's how we have this equation right here. And so we basically just plug in what we know. We're looking for the angle measure. Sorry. Angle measure is half the measure of the inscribed arc. Our arc is 48 right here. Right, this would be our arc, C to B. And so we just solve what is half of 24. Half of 24 is 40. Half of 48, sorry, is 24. And so A would in fact be our answer. Great job, guys. So central angles and its arc is equal to each other. Inscribed angles and its arc is half. So the inscribed angle is half the measure of the arc. Wonderful job. Okay. Now we're going to get into the angle formed by a tangent and chord theorem. This theorem states, if a tangent to a circle and a chord intersect at a point on the circle, then the measure of each angle that is formed is 1/2 the measure of its inscribed arc. So, just a reminder, our tangent runs outside of the circle. So this is our tangent. And it meets the circle at a point of tangency, right? We saw this in our last lesson. What it's saying is if this tangent meets a chord running from 1/2 of the circle, or one part of the circle to the other side of the circle, what it is saying is the angle that is created, both of the angles which are created, are half the measure of the arc. So this blue angle, its arc will be this one right here. That will be its arc. And this yellow arc would be this one. So the measure is the measure inside or between the tangent and the chord, the angle created, is half the measure of our arc. Okay. So this is saying the measure of KJN is 92. So this is 92. Then what is the measure of arc? JMK. So given that information, what is the measure of this arc right here? Okay. And I will launch the poll. Or you can put it in the chat box. So we're looking for what is the measure of arc JMK? Given that we know that the measure of each angle formed is 1/2 the measure of its arc. I'll give you about 45 seconds to look at this one. About 15 more seconds. Okay. And so we're given information about KJN, which is this angle right here. What we notice is that KJN is created by a tangent and a chord, right? Therefore, we can use the angle formed by a tangent and a chord theorem, which tells us that the measure of each angle formed is 1/2 the measure of its inscribed arc. So we use this equation right here. Inscribed angle is equal to 1/2 the intercepted arc. So our angle is equal to 92 equals 1/2 the measure of our arc. And we're looking for the measure of that arc, right? Arc JMK. Okay, so what we could do is multiply by 2 on both sides. And when we do so, we see that the arc is equal to 184. So this arc is equal to 184. Why is that? Well, because the angle is 1/2 the measure of that arc. So 184 divided by 2 is 92. And so therefore, D is our answer. Okay, good job, guys. Okay. Okay, now we're going to look at the first corollary to the inscribed angle theorem. And this basically says, if two inscribed angles that intersect the same arc are congruent. So two inscribed angles that intersect the same arc are congruent. Okay, so what does that mean? Well, let's look at this first example. We know that an inscribed angle has a vertex on the circle. Okay? And it has its sides, which are chords. So it runs from one side to the other side. Chord, chord. So that means we have one inscribed angle right here. What we also have is another inscribed angle right here, because its vertex is on the circle, and it has two sides, which are chords. Chord. And so therefore, we have another inscribed angle right here. Well, what we'll notice is that these inscribed angles, so let's look at this one first. Its inscribed arc is right here, or intercepted arc is right there, right? Well, let's look at the other inscribed angle. Well, we'll notice it has the same arc. And because it has the same arc, what we can say by that is that those two inscribed angles would be congruent. So, for example, if this is 70, then this would also be 70. So because they share the same arc, and they are both inscribed angles, then those two would be equal to each other. What you'll notice is we also have other inscribed angles in this image. Here's our vertexes. And they also have sides which are chords, right? And what you'll notice is they also share a common intercepted arc. One right there, and another right here. And so because they are both inscribed angles and they both share a common arc, then they too are equal to each other. So if this was 80, then this would also be 80. So two inscribed angles that intercept the same arc are congruent. So that's the first corollary to the inscribed angle theorem. Okay, let me launch the next poll. This one says angle BAC is 56 degrees. So this is 56 degrees. Oops. This is 56 degrees. What is the measure of BDC? You can go ahead and put in the chat box or answer the poll. And I'll give you guys about 45 seconds again. Let us remember that two inscribed angles that intersect the same arc are congruent. So what does that tell us about our missing angle? About 15 more seconds. Okay, so we know that two inscribed angles that intercept the same arc are congruent. So we know we have one inscribed angle right here, right? We have a vertex, and an angle is formed with two chords on both sides. Chord, chord. What we'll notice is that BDC is also an inscribed angle because it has a vertex, and both of its sides are formed by chords. Chord, chord. And so what we want to identify is, do those share the same arc? So let's see. Its arc would be BC. And its arc would also be BC. And so because they share the same arc, they are congruent. And so therefore, this missing angle is also 56. So great job. And so therefore, B would be our answer. Good job, guys. Okay. Almost done. Now we have the second corollary to the inscribed angle theorem. The second corollary tells us that an angle inscribed in a semicircle is a right angle. So what is a semicircle? A semicircle is just basically half of a circle. So there is our semicircle. And what I could actually do is block out this part so you can see. We're looking at the top part of our circle, not this black part. Okay. So we have an angle inscribed in that semicircle. How do we know we have an angle inscribed? Because we have a vertex, which is on the circle. And we have sides, which are created by chords. And so because that inscribed angle is located on the semicircle, then what we know about from that is that that angle must be equal to 90 degrees. So if we have an inscribed angle, which is located at the semicircle in half of a circle, then that inscribed angle is equal to 90 degrees. Okay. And so now we're going to use that information to answer this question. But let me just briefly go over it. It says line segment BD is the diameter. what is the measure of BC? So we're looking for, or what is the measure of arc BC? So we're looking for the measure of this arc right here. And what we're going to have to do is put together some information that we know already. So I'll give you guys about a minute to look at this one. Again, answer in the poll or the chat box, and then I'll go over it with you. Okay? So take about a minute to answer this question. About 30 more seconds. $15 seconds. You can see quite a bit of us already answering the poll. All right. So here what we see is that we have an inscribed angle inside of a semicircle. So semicircle. And so because of that, we can disregard this side of the circle. Okay. Our angle which is inscribed in this semicircle is this one right here. We have a vertex. Sorry. And two sides which are made out of chords. Chord and a chord. Well, what did we learn about the second corollary? We learned that that means that this angle is equal to 90 degrees. Okay, but the information we're looking at is information about our arc BC. And so because we're looking for information about our arc BC, what we want to be looking at is identify what is the measure of this inscribed angle right here. Why is that? Because its arc is arc BC. This one. And so I want to identify what is the measure of that angle BDC. What is the measure of that angle? What do I know about triangles? I know that the interior angle of a triangle is equal to 80 degrees. So that means I can take 180 minus 51 plus 90, which gives me 180 minus 141 is equal to 39 degrees. So this is equal to 39 degrees. Okay, now what do I know about an inscribed angle and its arc? I know that an inscribed angle is half the measure of its arc. So I can use this equation right here. Times 2 times 2. 39 times 2 is 78. And so that means that the measure of my arc, BC, is equal to 78 degrees. So basically what I'm doing is I'm using the second corollary of the inscribed angle theorem to solve for this angle right here. That angle is obviously 90 according to the inscribed corollary of the according to the second corollary to the inscribed angle theorem. Okay? But I know that I need to find the measure of arc BC, which means that I need to find the missing measure of this inscribed angle, right? And that's 39 degrees. And what do I know about the inscribed angle and the arc? The inscribed angle, not that one. The measure of each angle formed is half the measure of the accepted angle. So 39 times 2 would give me 78. Okay. So we use information both about what we know about triangles in this one and what we just learned about circles. Okay, the last theorem we're going to look at today is the third corollary to the inscribed angle theorem. And this one just says, opposite angles of a quadrilateral inscribed in a circle are supplementary. So if we have a quadrilateral which is inscribed, so inside of a circle, the opposite angles are supplementary. So that means that this angle and this angle are supplementary. What do we know about supplementary angles? They're equal to 180 degrees. So A plus C would give me 180. And D and B would give me 180. So that's basically what I'm getting out of here. Okay. And so that will allow me to solve this problem, and I'll go ahead and show you how we'd use this. So we're going to use the third corollary to the inscribed angle theorem, which basically says the measure of angle Q is x plus 2. The measure of angle S is 9x minus 7. What is the measure of angles Q and S? Well, I know that these are opposite angles. Why? Because they're opposites of each other. We've looked at that already before. And the third corollary to the inscribed angle theorem tells me that opposite angles are supplementary, so they're equal to 190 degrees. So that means that I can add those two together. And they need to equal to 180 degrees. And when I do so, this is 10k minus 5, 180. Isolate my x, plus 5, 185. Further isolate my x, 10, 10. X is equal to 18.5. And I want to find the angle measures of Q and S. So basically, I'm just plugging that back in. So 9 times 18.5 minus 7, 159.5. So that angle S is equal to 159.5. Now what's the measure of angle Q? Do the same thing. 18.5 minus, or plus 2, sorry, is equal to 20.5. 20.5. And what you'll notice is if I were to add those together, I would get 180 degrees. So those two are in fact supplementary. Okay, any questions about this? Questions, concerns? Okay, so today we looked at a variety of theorems for circles. And we learned a lot about inscribed angles and their arcs. The biggest one is that the measure of an inscribed angle is half the measure of its inscribed arc. We also learned that two inscribed angles that share the same arc are congruent to each other. We also learned that an angle inscribed in a semicircle is always a right angle. And lastly, that the opposite sides of a quadrilateral inscribed in a circle are supplementary. So the opposite angles of a quadrilateral inscribed in a circle are supplementary. And this one, if a tangent and a chord intersect on a circle, the measure of each angle they form is half the measure of its inscribed arc. Right? These are basically just a synthesis of all the different theorems that we looked at today. Does anyone have any questions about anything we've gone over today? And we will do some more review once we come back from spring break, but any questions? No? Okay. And so before you exit today, please just put in the chat box one thing that you learned today. Any one thing. And as soon as you type something, you can go ahead and log out. And I will see you guys on Tuesday. Bye, guys. So any one thing just to solidify that before spring break? What is one thing that you learned today? In the chat box, and then you can look out. Okay? Bye, guys.